Hi everyone, in this video I'm going to show you how to assemble the Quantum Outlet Switch DIY kit and connect it to the Quantum system so you can use it for your next project. The Outlet Switch DIY kit can control the power provided to a device, like a small room, fan, or heater, as well as provide the current usage of the attached device by connecting it to the Quantum system. It takes in up to 240 volts AC or 30 volts DC at 10 amps and uses a relay switch to power the outlet on and off. The kit also includes a current sensor to provide current usage data of the attached device to the Quantum system. Before we get started on assembling the DIY kit, I would first like to show you our documentation page for this product. This page will provide you with all the information regarding this product, such as a description of the kit, projects we have made with the kit, and most importantly, the designators to tell you where to solder each component. I'll have a link for this page in the description below, or you can also scan the QR code found on the packaging. To solder the components onto the PCB, I will be following the designators found in the documentation. For example, where it says R1 on the PCB, I'll place the resistor designated as R1 in the documentation and solder it to the board. Once you have completed soldering the components provided, you'll see that there are still a few parts that must be attached. Among the parts, you'll see some brass standoffs, metal screws, plastic standoffs, and plastic screws. Start by connecting the male to female brass standoffs to the female to female brass standoffs. Next, connect them to the PCB here and here. These will be used to mount your builder base to the kit, but don't do that yet because there are a few more steps before we do that. Now screw in the plastic standoffs here and here. This will be used to mount your current sensor, but don't do that yet also. Make sure to trim the plastic screws slightly using cutters so they fit into the standoffs from both sides. Now it's time to connect male-to-male jumper wires to the green terminal blocks on the kit. You will connect these to the builder base later on. Under the terminal blocks, you'll see that they're labeled. You can use this as a reference for when you connect them to the builder base. The in terminal is to control the relay switch. The out terminal is to receive data from the current sensor. The ground terminal is to ground the builder base, and 5 volt is to power the builder base. Next, connect your AC power source to the DIY kit. Instead of assembling this kit directly into a wall outlet, I'll be connecting it to a standard extension cord since it provides easy mobility between projects. Start by stripping off the main insulation of the extension cord. Inside there will be 3 wires, a green, white, and black one. The green is your ground, white is your neutral, and black is your hot. You'll need to cut the white and black wires to connect to the kit. You can leave the green one untouched or make sure to reconnect it if you cut that one as well. Now strip the ends before connecting them to the kit. Since you'll be connecting AC power, we highly recommend using terminal connectors on the end of each wire before connecting it to the kit. This will prevent the copper strands in the wire from fraying and possibly shorting the circuit and causing bigger problems. Once the wires are ready to be connected, on the bottom of the kit you'll see the labels under the blue terminal blocks which will tell you which wires go where. You can also follow the schematic here. Hot is where you'll connect the incoming hot wire. This is the black wire that is on the side of the extension cord that you'll be plugging into the wall outlet. The neutral terminal next to it is where you'll connect the incoming white neutral wire. The second neutral terminal is where you'll connect the outgoing neutral wire. This is the white wire that is on the side of the extension cord that will be connecting to the device you wish to power. Now before you connect the outgoing hot wire to the kit, you will need to mount the current sensor onto the plastic standoffs with the terminals facing outward like so. Next, take a piece of electrical copper wire and connect either the hot normally closed or normally open terminal to the in terminal of the current sensor. In this video, we'll be using the hot normally closed terminal. Also, make sure you are using electrical wire that can handle high AC voltage because jumper wires will not do. Now, connect the black outgoing hot wire to the out terminal on the current sensor. Once you've done that, connect the provided jumper wires from the pin headers on the PCB to the pin headers on the current sensor. Lastly, mount the builder base to the brass standoffs and connect those jumper wires. You can follow this schematic here. Connect the in terminal to GP0 on the builder base, the out terminal to GP1, ground to any ground terminal on the builder base, and 5 volts to the 5 volt terminal. You have now completed the assembly for your outlet switch DIY kit. Go ahead and plug the extension cord into a wall outlet and you'll see the builder base power on. Once that happens, go to your Q server to complete the rest of the setup. So now that we're on the home page of the Q server, the first thing we'll need to do is pair that client that we attached to the outlet switch DIY kit. To do that, we're going to go to the Clients tab, and then go to the Unpaired tab, and then you should see that client appear. We'll go to Actions for it, and then select Pair. Once the client is paired, let's go ahead and click Setup. For the name, we will name this Heater Outlet Switch, since we'll be controlling a heater with it. For the location, let's go ahead and put in Living Room, and then click Save. Now that the client is paired and we have given it a name, let's go ahead and create the firmware for this, and then we'll upload it to the builder base. To do that, we'll go to the Firmware tab here. We'll click Create New. We'll give it a name. We'll go ahead and name this Heater Outlet Switch as well, and then click Create. Now there's two types of hardware that we need to add to this firmware file. The first one is going to be a digital out hardware. So we'll go to click Add Hardware, select Digital Out, and we'll give it a name. I will name it Switch, and then click Add Hardware. Now the second one is the current sensor. So we'll go to Add Hardware, we'll search for Current, and then we'll name this Current Sensor, and then we'll click Add Hardware. Now let's go ahead and configure both hardware in the firmware file. For the switch, I'm going to configure the driver. The driver is going to be GPIO. For the pin, I connected that to GP0 on the builder base, so I'll select GP0. And then for the mode, it's going to be initially low. Now moving on to the current sensor. For the driver, there's only one currently. It's the ACS712, which is part of the DIY kit, so we'll select that one. For the pin, I connected that to GP1, so I'll select that one. The resolution, I'll keep it at 10 milliamps. And then for the ACS model, you will see this on the actual sensor itself. However, the one that we provide you is 30 amps. So we'll select that one and then click Save. Once you have created your firmware file, let's go ahead and upload that to our outlet switch builder base. So we'll click Actions, we'll click Upload, and then we'll select that heater outlet switch builder base, and then click Upload. Now while that's uploading, let's go ahead and create a very basic app to get started. So I'll just quit out of this. We'll go to the Apps tab. I'll click Create New, and then I'll name this Heater Outlet Switch as well, and then click Create. Now just like what we did with the firmware, let's start by bringing out the two types of hardware that we have on the DIY kit. The first one will be the digital out, so I'll bring that one in. And then the next one will be the current hardware object. So I'll position those just like this. Now to control these two hardware objects, we'll need some interface objects. The first one is to control the relay switch using the digital out hardware. I will bring in a switch interface object and then bring it into here. And then the next one is a simple text interface object, and that's what we're going to use to read the current data coming from our current sensor, and then we'll be able to read it on our dashboard. So we have brought out all the objects we need for this simple application. Let's go ahead and name these real quick just to make it easier for the mapping process and to see it on the dashboard. So for the current, I'll just name it current sensor, click Save Properties. For the corresponding text interface object, let's just call it current usage. And then I'll do the same for the label and then click Save Properties. And then for the switch controlling the digital out hardware object here, we'll just name this one on off, click Save Properties. And then for the digital out hardware object, let's just call this switch and then click Save Properties. So now that we have created the application, let's save the app. Let's go to Return to My Apps. We're going to click the play button to run this application. Now we're going to have to map the hardware objects that we created in the application and map it to the firmware hardware that we uploaded to the builder base. So for the current sensor, we will click the client. We'll see there's the heater outlet switch client with that current sensor hardware. We'll map it to that one. And then for the digital out switch, same client with the switch hardware in it. So we'll select that one. Now let's click Save and Run. Now that the application is running, let's go to the dashboard to control the hardware that's connected to the outlet switch DIY kit and that builder base. So here is the application. I'll select that one. So let's go ahead and turn it on. My heater is now on. You might be able to hear it in the background, and you can see the current usage has skyrocketed and it's now up to 5,000, 6,000 milliamps and climbing. And then when I turn off the heater, you'll be able to see that the current usage will then drop. So that's just a simple application on how you can control a piece of hardware as well as read the current that it's drawing from an outlet. So let's go ahead and take this one step further and create a true automated project where you can control a device on and off, read current usages, and so forth. So I'm going to go back to my apps and then build an automated app and show you guys how it works. So here's the application that I've created. What is happening here is I am pulling the data from our current sensor, and I will be able to display this onto a time graph using a series of historic data, timestamp, and time graph objects. And then I'll be able to see it on the dashboard, and then I can see my current usage over a period of time with the heater connected to the outlet switch DIY kit. Additionally, I'm also able to control the switch of the DIY kit using the on and off switch interface object that we used in the previous application. However, that's not in the spirit of automation, so I took it one step further. I've included a couple more code objects and some more interface objects, and what this will do is mimic a temperature control portion of the program. So I have a set temperature input number interface object where I can set a temperature that I want it to ideally be. And then I have a variable temperature input number. Typically, you would have a temperature hardware object for a DHT11 temperature sensor to do this. However, the data that comes in is pretty slow, so I want to show you the real results pretty quickly. So we're going to be using this instead. And what this will do is compare the incoming temperature from a sensor with the set temperature that I want in, say, a given room. And if the room's temperature is greater than the set temperature that I want it to be, it'll turn off the heater. But if it's less than the set temperature, it will turn on the heater. And then it will continue to display the current usage for the heater as well. So this is the application. I will go ahead and click Save App. We'll return to My Apps. I'll click the play button for that new application here. My hardware is already mapped to the hardware objects in the application. So we'll click Save and Run. And then I'll go to the dashboard. Now here is the dashboard. You can see the time graph that's happening. It's already running. I can control the heater on and off. I can delete the data. Here is my incoming variable temperature and then my set temperature. So we'll just start by turning on the heater. And when I do that, you can see over a period of time, It's going to change the y-axis is based on milliamps here. So now you can see that the milliamps has skyrocketed when I turned on the heater. Now it's changing. And now when I turn it off, you'll see that the milliamp usage will now go down. There's a little bit of a delay with the incoming data compared to when it happens, so you just have to give it a few seconds. Now you can see that the milliamps have dropped. Let's go ahead and set a temperature that I want a room to be. Say I want it to be 70 degrees. Now when the incoming temperature from a sensor reads that it's 60 degrees, it's going to turn on the heater and you should be able to see the milliamp usage go up. So now we can see the current usage went up and it's continuing to stay up because the heater is on. Let's say now that the temperature reads at 80 degrees in the room and I still want it at 70 degrees. The heater is now turned off and now you're going to see a drop in current usage. So there you go. Now the heater is turned off. You can see the decrease in the current usage. Now if you want to delete the data, what you can do is click that clear all button, and then in a few seconds here you'll see that the data is wiped and it'll start from that point when I click the clear all data. So there you go. That's how you can use the outlet switch DIY kit with the Quantum system to create either a simple program or an automated program to control appliances that are connected to it. Make sure you check out the links in the video description below for more information about this kit and how to use it with the Quantum system. Hope you enjoyed this video and thanks for watching.